Welcome to Cognitia. Today, we're exploring one of the strangest objects in existence. Black holes are among the strangest objects in existence. They seem to defy common sense. Where do they come from? And what would happen if you fell into one? Stars are incredibly massive collections of mostly hydrogen atoms, formed when enormous clouds of gas collapse under their own gravity. At a star's core, nuclear fusion crushes hydrogen atoms into helium, releasing a tremendous amount of energy. This energy radiates outward, pushing against gravity and creating a delicate balance. As long as fusion continues, the star remains stable. However, stars much more massive than our Sun follow a different path. Their intense heat and pressure allow them to fuse heavier and heavier elements until they reach iron. Unlike previous elements, iron fusion produces no energy. As iron builds up in the core, the balance between radiation and gravity suddenly collapses. In a fraction of a second, the star implodes. Matter falls inward at nearly a quarter of the speed of light, feeding the collapsing core. At this moment, as the star dies in a supernova explosion, all the heavier elements in the universe are created. What remains afterward is either a neutron star, if the core is massive enough, a black hole. If you were to look at a black hole, what you'd actually see is the event horizon. Anything that crosses this boundary would need to travel faster than the speed of light to escape, which is impossible. As a result, the black hole appears as a perfectly black sphere, reflecting nothing. But if the event horizon is the black part, what is the whole part? At the center lies the singularities, something we don't fully understand. It may be infinitely dense, with all its mass compressed into a single point with no volume or surface. Or it may be something entirely different. Right now, we simply don't know. It's like a dividing by zero error in physics. Despite popular belief, black holes don't suck things in like cosmic vacuum cleaners. If the Sun were magically replaced by an equally massive black hole, Earth's orbit would remain unchanged, though we'd freeze to death without sunlight. So what would happen if you fell into a black hole? Time behaves very differently near one. From an outside observer's perspective, you would appear to slow down as you approach the event horizon. Eventually, you'd seem to freeze in time, turn red, and fade away. From your own perspective, however, you'd see the universe outside speeding up, most like watching the future unfold. What happens next is uncertain. But physicists believe one of two things would occur. First, you might die a slow and horrifying death. Inside a black hole, space is curved so extremely that once you cross the event horizon, there is only one possible direction: forward. Gravity becomes so uneven that even tiny differences in distance cause immense forces. Your body would be stretched atom by atom in a process called spaghettification, until you become a thin stream of plasma. Second, you might die a very fast death. Some theories suggest you would encounter a firewall just beyond the event horizon, destroying you instantly. Neither option is pleasant. How long you survive depends on the black hole's mass. Small black holes would tear you apart before you even cross the event horizon. In contrast, you could potentially travel inside a supermassive black hole for quite a while. As a rule of thumb, the farther you are from the singularity, the longer you live. Black holes come in different sizes. Stellar mass black holes contain a few times the mass of our Sun and can be as small as an asteroid. Then there are supermassive black holes found at the centers of galaxies, feeding for billions of years. The largest known supermassive black hole is S50014+81. It has 40 billion times the mass of our Sun and a diameter of 236.7 billion kilometers, about 47 times the distance from the Sun to Pluto. As powerful as black holes are, they are not eternal. Over unimaginably long timescales, they slowly evaporate through a process known as Hawking radiation. Even so, the largest black holes may take a Google years to disappear. By then, the universe will be cold, dark, and uninhabitable. No one will be left to witness their final moments. And this still isn't the end of the story. There are many more fascinating ideas about black holes, and we'll explore them in part 2. This is Cognitia. Stay curious.